Hello everyone and welcome to another video on our own devices. I'm Jean Messier and today we're having a look at a very cool piece of mid-century consumer electronics. This is a Space Command 600 introduced by the Zenith Radio Corporation in 1956, and this was the world's first commercially successful wireless television remote. And before any of you boomers out there chime in the comments, yes, I've heard the joke, your family had a wireless remote before 1956 and it was you. Anyway, while today television remotes are pretty ubiquitous and unremarkable pieces of technology, this one is really cool, not just because it was the first, but because it doesn't work the way you probably think it does. Let me show you what I mean. Now, the history of the Zenith Radio Corporation is a long and fascinating one, but a bit beyond the scope of this video. But very briefly, the company started out as Chicago Radio Labs, founded in 1918 by radio amateurs Ralph Matthews and Carl Hassel. Originally based out of a literal shack at 5525 North Sheridan Road in Chicago, the company initially specialized in the manufacture of amateur radio equipment. Then, in 1921, Matthews and Hassel obtained a license to manufacture the regenerative receiver circuit invented by radio pioneer Edwin Armstrong and, with the help of U.S. Navy Lieutenant Commander and financier Eugene McDonald, incorporated as the Zenith Radio Company. Interestingly, while Zenith, of course, means peak or apex, the name was actually inspired by the company founder's ham radio call sign, 9ZN. Zenith quickly established a reputation for manufacturing high-quality, innovative consumer products, introducing the first portable consumer radio in 1924, the first mass-produced plug-in AC-powered radio in 1926, the first radio with push-button tuning in 1927, and the Zenith Radio Nurse, the world's first electronic baby monitor, in 1938. And in 1940, Zenith launched one of the first FM radio stations in the United States, WWZR or WEFM, now WUSN. Indeed, in the 1920s, the company was instrumental in the implementation of the so-called Chicago Plan, which allowed the city's various competing amateur radio clubs to share the airwaves, a precursor to modern FCC regulations. Now, Zenith introduced its first television set in 1939, but the outbreak of the Second World War curtailed most commercial television development, so the sales of commercial Zenith televisions didn't resume until 1948. These early sets were notable in that they used circular porthole screens that were not rectangularly cropped like those of most competitors. Other notable Zenith products from this era included the Transoceanic series of shortwave radios and the Royal series of transistor radios, considered among the best on the market. And in 1951, Zenith became one of the first companies to experiment with subscription television, i.e. pay-per-view, in the form of its Phonovision system. This comprised a descrambler box connected to the television set and to the telephone line, and to use it, the subscriber would call up the broadcast station, who would then connect the desired program to that particular household. Now, while Phonovision was completely experimental and was never implemented at scale, the results were highly telling, with 92% of subscribers indicating that they would prefer to watch movies at home rather than in a theater. So yes, they were experimenting with proto-Netflix all the way back in the early 1950s. By the early 1960s, the company was one of the two largest manufacturers of televisions in the country, along with RCA, with both firms controlling around 20% of the market each. At this time, Zenith employed around 11,000 people in 7 main plants and 2 subsidiaries, Rowland Corporation and Central Electronics, in and around Chicago. And all this finally brings us to television remote controls. Zenith introduced the first successful television remote, the amusingly named Lazy Bones, in 1950. This sold for $30, around $400 today, connected to the television set via a long cable, and had 2 buttons, one for tuning and one for volume control, which operated servo motors connected to the regular control knobs. Interestingly, the same thinking behind the creation of Phonovision also inspired the Lazy Bones. See, company co-founder and by then president Eugene McDonald believed that consumers would eventually get tired of television commercials and that the whole commercial television model would collapse. So he was always looking for ways of eliminating commercials altogether, or in this case, allowing consumers to turn off the volume during the commercial breaks. Now, while the Lazy Bones sold fairly well, people complained about the cable, which was not only unsightly, but also presented a tripping hazard. And so McDonald instructed his engineers to come up with a wireless version. The first of these, the Flash Matic, was developed by engineer Eugene Pauly and released in 1955. This was a gun-type device containing a directional light bulb, signals from which were received by 4 photocells mounted on the corners of the television cabinet, one pair for changing the channel and the other for turning the sound on and off. Now, while the system worked well enough, unfortunately it was found that the photocells were far too sensitive to full spectrum light and could easily be triggered by, say, sunlight streaming through the window, and so the Flashmatic was pulled from the market after only a year. Now, the next most obvious solution would be to use radio waves, but this was actually pretty quickly rejected for a number of reasons. For example, radio receivers of the era had fairly poor frequency discrimination and were thus highly susceptible to interference. It was also feared that the radio waves from the remote would penetrate walls and set off television sets in other rooms and even neighboring houses. Finally, company president Eugene McDonald was dead set against the remote using batteries. And while this might seem like an odd requirement, you have to remember that batteries were mainly used in things like flashlights and transistor radios. And it was feared that if the batteries in the remote ran down, the television user would assume that there was something wrong with the television set and not the remote. Thankfully, though, Chief Engineer Robert Adler came up with a unique solution that fulfilled all of these requirements, and this eventually became the Space Command Remote, released in the fall of 1956. So let's have a closer look at this example, and let me show you how it works. So I absolutely love the mid-century styling of this remote. It looks straight out of Star Trek, the original series. This particular version is the Space Command 600, introduced in 1965 and designed for use with color TVs. It thus includes controls for adjusting the color balance of the display. Going left to right, we have buttons for channel lower or red hue, on-off, mute, and channel higher or green hue. To use the hue control, you press the mute button, which signals the television to flip a relay, transferring the channel button signal from the tuning system to the color control system. Pressing mute again, switch control back to the tuning system. The original 1956 Space Command also had 4 buttons, but with slightly different functions: channel lower, sound on-off, television on-off, and channel higher. And pressing these produces a nice satisfying click, which is why television remotes soon became known as clickers. If we flip this over, we can see a list of patents molded into the rear cover, as well as 4 screws. And if we remove those and pop off the bottom cover, we find 4 solid aluminium rods. No batteries, no lights, no transmitters, no electronics of any kind. And that's because this is an entirely mechanical system based on sound. See, pushing the buttons draws back and releases small spring-loaded hammers which strike the ends of these aluminium rods. Each of these is supported in the middle, so it undergoes longitudinal vibration and is precisely machined to vibrate at a particular frequency when struck. Now, Zenith engineers initially considered using audible frequencies, but realized that this would get really annoying really quickly, and since producing infrasound was not technically feasible, all that was left was ultrasound. Now, I haven't found any documentation stating which frequencies were specifically used in this model, but according to the original patent, the rods were machined to half the wavelength of their resonant frequency. Left to right, the rods measure approximately 61, 65, 67, and 64 millimeters long, while the average speed of sound in aluminium for longitudinal waves is around 6,370 meters per second. So dividing that speed by twice the rod lengths yields resonant frequencies of 52.2, 49, 47.5, and 49.8 kilohertz respectively. Furthermore, the diameter of the rods equals one wavelength at the resonant frequency in air for good efficiency in radiating the acoustic signal. In this case, 8 millimeters or 4.2 kilohertz, assuming a speed of sound in air of 343 meters per second at 20 degrees Celsius. Also, according to the patent, the longitudinal vibration mode was chosen over other modes such as flexure because the rate of energy loss is lower in this mode, allowing for a longer time constant. That is the time it takes for a damped oscillator to reach 63.2% of its final amplitude. This is important for signal discrimination reasons, which we'll get to in a moment. Achieving a high time constant in flexure mode also requires the use of denser materials, greatly increasing the weight of the remote. And while high carbon steel would theoretically work, the resonant frequency is highly dependent on the drawing temperature of the metal bar. Furthermore, the resonant frequency of a bar in flexure is linearly proportional to its thickness and inversely proportional to the square of its length, meaning that a flexing steel bar would need to be machined to extremely fine tolerances. By contrast, aluminium is lightweight, exhibits low internal damping, and has a time constant on the order of 0.3 seconds, and allows the generation of frequencies in the 40 kHz range using a resonator small enough to fit in a handheld remote. Now, please excuse that extremely nerdy tangent. As a former engineer, I just found the very careful thought that went into the materials and geometry selection in this remote to be absolutely fascinating. Now, aside from the click of the hammer striking the bars, the frequencies produced by this remote are inaudible to the human ear, could trigger a television set from around 30 feet or 9 meters away, and had the added advantage over the earlier Flashmatic of not having to be aimed directly at the television set in order to work. Now, of course, this is only half the system. The television set also had to be equipped with a receiver circuit to detect the electronic signals from the remote and convert them into electric control signals. Here is a schematic of that system from the original patent. In addition to the expected microphone, audio filters, and amplifiers, this also included a discriminator circuit to help prevent the system from being accidentally triggered by ambient sounds of similar frequencies to those produced by the remote. And this took advantage of the aforementioned time constant of the resonator bars, which was likely to be much longer than that of any natural sound of the same frequency. So this integrated incoming signals and only allowed through those whose integrated signal strength passed a certain threshold. Now, the last feature worth pointing out is the damping system. So if the bars were allowed to just keep resonating, that persistent signal might cause either the volume or the channel tuning knobs to overshoot their desired position. Thus, the hammer mechanism is designed to push each resonator bar against a damper wire immediately after striking, causing the vibration to quickly decay away and preventing overshoot. Now, despite its many advantages, the Space Command system was not without its flaws. For example, certain natural sounds, particularly the jangling of keys, could still accidentally trigger the receiver, while the frequencies produced by the remote were audible to animals like dogs. And finally, the addition of the receiver circuit added a full 30% to the cost of ordinary television sets. Nonetheless, the system proved extraordinarily successful, helping to boost the sales of Zenith televisions by a full 40%. The original mechanical system was licensed out to a number of companies and remained in production until 1972, when it was replaced by a similar design which generated signal tones electronically. Some 9 million ultrasonic remotes were manufactured between 1956 and the 1980s, when they were finally supplanted by infrared systems using LEDs. And to learn more about an early version of this technology, please check out my previous video on the Kodak Carousel IR remote control, link in the description. Interestingly, the development of the wireless remote was considered such a milestone that in 1997, Eugene Pauly and Robert Adler received an Emmy Award from the National Academy of Television Arts and Sciences for their work on the Flashmatic and Space Command. Now, from this point on, Zenith continued to go from strength to strength, introducing some of the first HDTV sets, becoming a leading supplier of cable modem boxes, and even entering the personal computer market by acquiring Heathkit. However, in the early 1970s, they started facing increasingly stiff competition from Japanese firms. And in 1970, they teamed up with Sears Roebuck and Motorola to launch a lawsuit against Japanese electronic manufacturers, accusing them of violating the 1916 Antitrust Act. This lawsuit dragged on for nearly 2 decades until 1987, when, after a number of appeals, the courts finally ruled in favor of the Japanese. By this point, Zenith had become the sole American manufacturer of television sets, and feeling highly vulnerable to a hostile takeover, entered a technology sharing agreement with Korean firm Goldstar, today LG Electronics, in 1990. However, even this failed to save them, and in 1999, Zenith filed for Chapter 11 bankruptcy and was wholly acquired by LG. And that, dear viewers, is a brief overview of the Zenith Radio Corporation and their highly innovative Space Commander remote control system. Now, ever since I first heard about this technology, I've really wanted to cover one on this channel, so I was very happy to finally come across an example. I hope you enjoyed that. Thank you so much for watching. I'll see you next time in another video where we'll look at yet more fascinating consumer electronics and other devices just like this one. Until then, I'm Jin Messier from Our Own Devices.